Lymph means clear water in Latin, and it describes the fluid that flows through the lymphatic vessels and lymph nodes, which make up the lymphatic system. The three major roles of the lymphatic system, the reason we need it in the first place, are that it returns fluid from the tissues back to the heart, it helps large molecules like hormones and lipids enter the blood, and it helps with immune surveillance to keep infections from running amok. So let's take a closer look at lymph and where it comes from. The blood in the arteries is under a lot of pressure because it needs to reach every little nook and cranny of the body. Those arteries branch out into narrower and narrower arteries, and then arterioles until finally it gets to the capillaries, which have walls that are only 1 cell thick and are slightly porous. Red blood cells are too big to fit through the capillary pores, but small proteins like albumin and fluid can make it through. Every day, 20 liters of fluid, water, and protein seep out of the capillaries and becomes part of the interstitial fluid between the cells. About 17 liters gets quickly reabsorbed back into the capillaries, but that leaves around 3 liters of fluid behind in the tissues each day. This 3 liters of fluid needs to find a way back into the blood so that the body's interstitial fluid volume and blood volume both stay constant over time. That's where the lymphatic vessels, or just lymphatics, come into play. They collect excess interstitial fluid and return it to the blood. Once the interstitial fluid is in the lymphatic vessels, it's called lymph. You might be wondering how there can be 20 liters of fluid seeping out each day if the blood volume is only 5 liters. Well, remember that the 5 liters is constantly in motion, and that it gets recycled over and over every single day. Unlike the circulatory system, the lymphatic system isn't a closed loop, because fluid and proteins make their way into the microscopic lymphatic capillaries, and all of the collected lymph is dumped into the veins. Lymphatic capillaries are the smallest lymphatic vessels, and they're located throughout the interstitial space. Lymphatic capillaries are extremely permeable because their walls are made of endothelial cells that only loosely overlap, forming one-way mini-valves. These endothelial cells are anchored to structures in the interstitial space by collagen filaments, which allows the lymphatic capillaries to stay flexible but retain their overall shape. When the pressure in the interstitial space is greater than the pressure in the lymphatic capillary, the endothelial mini-valves open up, allowing fluid to get in. When the pressure in the interstitial space is less than the pressure in the lymphatic capillary, the endothelial mini-valves are pushed shut, which keeps the lymph inside. Once that lymph is inside the lymphatic capillaries, it travels through bigger and thicker walled vessels, then trunks, and then ducts. There's no pump pushing lymph through the lymphatic system. Instead, smooth muscle in the lymph vessels reacts to the pulsing of nearby arteries by squeezing to get things started. And then the squeezing of skeletal muscles, which normally contract throughout the day, exert external pressure to keep the lymph flowing along, eventually reaching a nearby lymphatic trunk. To keep the lymph from sliding backwards, the lymphatic vessels have valves just like the veins do. The lymphatic trunks are each named after the regions of the body that they drain the lymph from. 2 lumbar trunks, 2 bronchomediastinal trunks, 2 subclavian trunks, and 2 jugular trunks, as well as 1 intestinal trunk. From there, the lymph is delivered to either the right lymphatic duct, which collects lymph from the right arm and the right side of the head and chest, or the thoracic duct, which is a lot bigger and collects lymph from the rest of the body. The right lymphatic duct dumps lymph into the junction of the right jugular vein and the right subclavian vein, and the thoracic duct dumps lymph into the same junction on the left side of the body. That particular spot is perfect because it's where the pressure is very low, which makes it easier for the lymph to flow in. The lymphatic system has key advantages. For example, it can pick up larger molecules, like hormones, that are too big to get into the capillaries, and then get them to the bloodstream. The lymphatic system can also help get nutrients to the tissues. For example, during a meal, fatty acids get packaged into balls of fat called chylomicrons by the small intestine. But just like the hormones, these are too big to move across capillaries. Instead, the chylomicrons go into special lymphatic vessels called lacteals, which get their name from the fact that the lymph that flows through them looks like milk. The chylomicrons slowly make their way up into the thoracic duct and get dumped into the venous blood. Now, the lymphatic system also plays a role in immune function. Lymphoid organs remove foreign material from the lymph to keep it from entering the bloodstream, and act as lookout points for the body's immune defenses. Some lymphoid organs are in the form of diffuse lymphoid tissue, where they're just a loose arrangement of lymphoid cells and protein, typically in the lining of the gastrointestinal and respiratory tract. Another type of lymphoid organs are lymph nodes, which are tightly packed balls of lymphoid cells and protein. Hundreds of lymph nodes cluster along the lymph vessels, each one a few millimeters to about 1 to 2 centimeters in size. When they're concentrated along the lymph trunks, you can feel them, especially in the neck, armpit, and groin. They can also be found in the intestinal wall, where they're called Peyer's patches. When an infection gets into the tissue, it can slip into a lymphatic capillary and move into a lymphatic vessel. Unfiltered lymph fluid drains into a nearby lymph node, where any pathogen or piece of a pathogen is quickly detected by a dendritic cell, which is a type of antigen-presenting cell that serves up pieces of anything it destroys to other immune cells. In the lymph nodes, dendritic cells continuously sample the lymph and present antigens that they come across to the B cells, which are a type of lymphocyte that can make antibodies. B cells are designed to only react to foreign antigens, and if the dendritic cell presents something foreign, the B cell turns into a plasma cell and starts cranking out antibodies, which then flow into the lymph and exit the lymph node. There are also circulating T cells, which are another type of lymphocyte that move between the lymph nodes, lymph, and blood, on the lookout for pathogens and infected or abnormal cells that have been tagged by antibodies. Another lymphoid organ is the spleen, which is about the size of a fist and sits on the left side of the body below the diaphragm and on top of the stomach. The spleen has both white pulp and red pulp. The white pulp is where antibody-coated bacteria are filtered out of the circulation and antibodies are generated by B cells. In a sense, the white pulp of the spleen is like a giant lymph node, although unlike a lymph node which receives unfiltered lymphatic fluid, the spleen receives blood. The red pulp of the spleen is where old and defected blood cells are destroyed, and their parts, which are the hemoglobin, the heme chain, and the iron, are either broken down or recycled. The spleen is also helpful in that it keeps red blood cells and platelets available in case they're suddenly needed by the body. Really, it's an organ that's got your back in an emergency. Another lymphoid organ is the thymus, which is in the upper part of the chest, just below where a necklace might sit. The thymus is most active in the neonatal period and pre-adolescent years, and then slowly atrophies and gets replaced by fat after puberty. The thymus is involved in the development of T cells, making sure that any T cells that react to self-antigens, antigens that are normally found in the body, are promptly destroyed. A final set of lymphoid organs worth mentioning are the tonsils, which include the adenoid, tubal tonsils, palatine tonsils, and lingual tonsils. Together they form a ring of lymphoid tissue around the throat, and their main job is to trap pathogens from the food you eat and the air you inhale. Alright, as a quick recap. The lymphatic system refers to the one-way network of lymphatic vessels that allows lymph, which is a clear fluid that's squeezed out of the blood, to transport nutrients to cells and act as a method of waste removal. Lymph is cleansed at lymph nodes throughout the lymphatic system, which play an important role in immune function.
Hey guys, Vince here. So I was thinking back to my college biology courses, and I don't remember being taught much about the lymphatic system. It just wasn't part of the curriculum. Now, granted, this was 15 years ago, but the lymphatic system is still a highly underappreciated system. So I hope that you found today's video educational. Today's script was written by Andrea Day. It was edited by Risha Desai. Tanner Marshall performed the voiceover, and I created the illustrations. If you'd like to support the creation of more of these types of videos, check us out at osmosis.org, where you'll find quizzes and flashcards and other educational resources that'll help you learn medicine. You can also subscribe to our channel on YouTube, follow us on social media, or donate to us on Patreon. All right. Thanks a lot, guys. Bye.